Hello. In this video, we want to look at an application. In this case, we're going to look at, kind of a physics application, or maybe chemistry, if you will. So the amount of grams in a sample of uranium-239 after T years is given by A of T equals 100 e to the negative 0.362 T. Find the rate of change of the amount present after 3 years. Okay, so first of all, we have a formula here. And this represents uranium-239 T years after T years. So here's the thing. This is what we call it's kind of like a compound interest question, but it's a negative interest question, if you will. So what it's going to look like when graphed is the following. And it's going to look something like this. And it's going to slowly approach zero that way. Now, this means that uranium-239 decays into some other element, or maybe some other isotope of 239. Some other isotope of uranium. I'm not really sure which it is, but it doesn't really matter because it decays into something else. That means that uranium-239 goes away. But we can model it using this equation. It's actually pretty good. So to do this, we want to go ahead and realize that the rate of change is what we want after 3 years. Now, first of all, we're going to look at this in two different ways. First, we're going to look at this as the rate of change at any given time t, and then figure out what it is at 3 years. So what we want to do is we want to go ahead and find a prime of t. And this formula is just an exponential expression. That's all it is. So just rewrite the 100, and then also the e to the negative 0.362 t. And then multiply by the derivative of the exponent. And the exponent is negative 0.362 t. So the derivative of that would be negative 0.362. Awesome. And then just simplify. Notice that 100 times that means I can move the decimal 2 places to the right, making this negative 36.2 e to the negative 0.362 t. And this is a prime of t. Now here's the thing, because this is in this form, this negative 0.362 is telling me the rate of change at any given time in terms of percentage. So it's every year is going to be reduced by 36.2% every single year. Okay. Now, notice that that actually is correct here, because notice if I do a prime of 0, if I plug in 0 here, that gives me e to the 0 power, and e to the 0 is just 1. That leaves me with negative 36.2. So in the first year, because you had 100 to begin with, it's reducing at 36.2 grams in that year. That's initially, though. What we want to know is what is a prime of 3? So let's think of that in terms of purple here. Okay, so to do that, just plug in 3 for t. That's going to give me negative 36.2, and then e to the negative 0.362 times 3. And then just type it in. So go to your calculator and type in negative 36.2. And then the e is second ln, so second ln, which is next to the 4. And then negative 0.362, 0.362, and then times 3. And then just click enter. And notice that it tells me it is negative 12.21981872. That is a prime of 3. And because we're talking about grams, let's go to the milligram, which means 3 decimal places. And so if that's an 8, that means that we round this up. So a prime of 3 is actually going to be negative 12.220 grams. Now, what that tells me is that at 3 years after whatever this time equaling 0 is, or in 3 years in the future, this 100 grams of uranium is going to be reducing, not in grams necessarily, but grams per year. This is in negative 12.220 grams per year. In other words, it's reducing the amount of uranium-239 in there by 12.220 grams per year at that time. Now, notice what's happening here is that initially that's what it looked like for the tangent line, and after 3 years, it's looking like this. So it's a shallower slope of the tangent line, and that's because the amount that's present is being reduced every single second. So over time, you have to reduce the slope of the tangent line in order to keep reducing every year by 36.2% of the amount that's present. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.